Welcome back, friends. So today we will have one more example to prove a particular language as a non-context free language. So let's just begin. So we have to prove. So the question is prove that the given L is non-context free language. So in this case, this X, this L is composition of every string of X having a composition of, it consists of A, B, C. So these are terminal symbols of that. This is valid input alphabets within this. So what it is saying, so total number of A's in X should be less than total number of B's in X. So the total number of B's must be greater than total number of A's, and this total number of A's are also less than total number of C's. So this pattern we will visualize in terms of X as A raised to n, the total n A's if we have. Now we wanted to make sure that this number of A's are less than B's. So we'll have this pattern B is n+1 and C raised to n+1, so that this condition satisfies. Now we wanted to prove this language as a non-context free language. So in this case, we'll go ahead. This is a pumping lemma for context free languages. So what it says, so these are the properties that every context free language must possess. So in this case, we are trying to we are saying that the language we are trying to prove that is a non-context free, we can prove it by contradiction. So in this case, by following, if we break up this a particular condition after pumping up and pumping down, if the resultant string, if we make to generate which is not in the language, we are easily proving that the language is non-context free language. To do this, and I'll repeat that this explanation of pumping lemma we have had multiple times within your previous lectures. So go back and check what this pumping lemma means. So I'm not going in depth of this right now. So we are following how to prove a particular this example of languages non-context free. So we have broken up this A raised to n, B raised to n+1, C raised to n+1 to make sure that total number of A's are less than total number of B's, and the same total number of A's are less than total number of C's. So in this case, we made it sure. Now the length of that window, what window we are saying, this window of VWX, where it should lie, we make sure that, see, this X should be broken up into 5 substrings. Length of Vx should not be null. We make sure VWX should be less than n, but where it should be available within that string, which is, we need to consider all such breakups. So case number 1 in this case is VWX is entirely lying within A raised to n. This is the condition number 1, where this window appears in this A raised to n. Okay. And second case is saying that this VWX entirely lying in second half of this. So few B's of this and few C's of this, it will consider. So what we are trying to make sure that if we pump up or pump down the resultant strings, either to make this n greater than this B or C, or to make sure that get a particular string after pumping and pumping down, this either B or C should be less than this A. Now this is what we wanted this condition to be the broken. So this condition number, case number 1, Now just see what case number 1 is. So this VWX is entirely lying this a raised to n. Now consider what constant is, consider any random constant which is n equal to 4. So what would be the string in this case? So I should have 4 A's, 5 B's, 5 C's. So X is 4 A's, 5 B's and 5 C's. So this is A raised to 4, B raised to 5, C raised to 5. And this is in the language. Now we wanted to make sure that, see this condition, you break up this string. Now entire VWX is entirely this is in A raised to n. So we make sure while breaking up this, so the part of V and X should not be null, and we made it correct. So I have my V part is not null, X part is not null. See this individual V and X have single A and single A. Now what we wanted is, in this pumping lemma, condition number 2 should be satisfied, where length of Vx should not be 0 and length of VWX, where the pumping will happen, it should be, the length of that should be less than equal to your constant. So in this case your constant is 4. So case number 1, if we break up this string into AAA, this length of the string is 3 AAA. So 3 A's are there, so length of VWX is 3. So this is surely that this is less than this n. So once both the conditions are satisfied, you start pumping up this constant. So value of I equal to 2, considering pumping up this pattern A. Now after pumping up this twice, so the substring V and X, what resultant string you get? So this U, you will get it as it is. See this V part has to be taken twice, as we pumped up this twice. W single, this X has to be repeated twice, and this Y is considered to be as it is. So after applying this rule, so what do you get? So I get 6 A's, 5 B's and 5 C's, which is not following this condition of a particular L. What condition says? Number of A should be less than number of B's, number of A should be less than number of C's, even after pumping up. So after pumping up, what I get? The total number of A's get increased. So surely this pattern is not in the language. Hence we proved that language is non-context free. What the condition number 2 is? So entirely this VWX should lie within this B raised to n and C raised to n. So we should make sure, considering this n equal to 4, I get this X, 4 A's, 5 B's, 5 C's. So break this X into UVWX, where consider VWX entirely lying within this two boundaries. I should capture few parts of B's and few parts of C's. So if we break something like this, I have this pattern where V and X should not be null, and VWX should be either less than or equal to the pumping lemma constant 4. So the length of this is 4. Now if I pump down, so I equal to 0. Why? So if I make I equal to 0, I should eliminate this V part and I should eliminate this X part. So I have this 4 A's, 3 B's common, this U part. In this V part should be eliminated, so I won't have this. So BC is W, what we have. X should be, this C should be eliminated, and left is this 3C. After pumping down means the value of I is 0, and applying this over a substring V and X, I got total number of A's are 4, B's are 4 and C's are 4. So all the A, B, C's are equal after pumping down, which is not the case that it should follow. What the pattern should be followed? Total number of A should be less than B and C. But all these three are same after this case number 2 when we apply pump down. So surely by those two cases we are proving that this language is not satisfying the pumping lemma for context-free language. So hence it is proved that the given L is non-context-free language. I hope you understood this. Thank you.